want to come move over here and talk. Welcome, everybody. We're going to go ahead and get started. We're so glad to have Josh Tobin here. Your company is Gantry, right? Or is it with the Gantry.io?
Mm-hmm.
Cool. He founded Gantry, formerly at OpenAI, and he's a recommendation from Joe Reese. Joe said, hey, reach out to Josh because he's a great speaker. So I did, and we're super glad to have him. Just as a couple reminders, if you have not joined the Forge Slack, feel free to do that. I can get you on there. You're also welcome to join the ML Ops community Slack. The ML Ops community has now started sponsoring this meetup, specifically as an ML Ops meetup. So we'll be having more Opsy content in the future. And I'm really excited about that. Did you have a question? It's just ML Ops _community. That URL will give you the link to the Slack. So Josh will be talking about iterating on production models today, which is a super relevant topic, I think, because I've only dealt with single deploy models that you just kicked out there and hope never died. So iterating on them is super important because, we'd like things to be live and up to date. So with that, Josh, I'm turning the time over to you. Feel free to introduce yourself and get started. If there's any questions, we have one mic here, and I'll pass it around so that they can ask you that question and you can hear them.
Sounds good. And remind me the timing.
We usually do between 30 to 45 minutes on talk. So
yeah, sounds good.
Anywhere between that.
And we're a small group, so if we can keep this pretty interactive, feel free to just jump in. I think when I go full screen, I probably won't be able to see you. So just feel free to interrupt. Or I'll try to pause at a couple points for questions as well. So thanks for the intro. I'm Josh, co-founder and CEO of a machine learning infrastructure startup called Gantry. I was at OpenAI for a while building deep learning powered robots. And I got really interested in the world of production ML a few years back when I was at OpenAI, and we were going through this transition period from being a very research oriented organization to like more of a product oriented startup. And there were all these questions that we had to figure out at that time, like what does our infrastructure look like? How can we write good unit tests for machine learning code? That to me just felt like there should be a good answer out there about them. This is probably 2017 before MLOps was really a term. And so that led to creating a class called Full Stack Deep Learning, where we aim to teach people like, hey, the math and the algorithms behind this stuff. What else do you need to know in order to make these technologies work in the real world? Through that class and the community around that is sort of what ended up leading to starting Gantry. And what I'm going to talk about today is refining machine learning powered products in production. So I think for, like machine learning models tend to degrade after they're deployed, but that's a shame because really like once you've deployed a model into production is the best chance you're actually going to have to make the model better, because that's when you're getting the most real data, which is data from your end users, which is like ultimately what we really care about. And so the quick outline of this talk is first I'm going to talk a little bit about what are ML-powered products. Then I'm going to sort of make the case for this thesis that ML-powered products should be refined in production. I'll outline what I see as seven of the core technical challenges to achieving that. We can go deeper on any of these if there's interest and we have time. And then I'll tell you a little bit about Gantry. So I think this kind of starts with an observation, which is, machine learning is very quickly becoming part of all of the software that we interact with. And that sounds like maybe an extreme statement, but I think in like 20 years time, machine learning is going to be much like software itself, where it's just, they're in the background doing a lot of things that we might not even notice it's doing, but it's actually contributing a lot to almost all the products or services that we interact with. And the problem is that like actually doing this well is really hard, right? So on one hand, there's all these products that exist now that just couldn't 4 or 5 years ago. So it's things like DALL-E 2 from OpenAI, TikTok, But it's not just products that are built by big companies. It's also, there's also tiny startups that are building amazing things. So Descript is a video editing tool that we use a lot for full stack deep learning. Flowrite is a sort of copywriting tool. And these tiny startups, tens or maybe 20s, like 20 something people are able to build these incredible products because the underlying technology, the modeling side of things is rapidly becoming commoditized, right? You can just go on Hugging Face, download a model that almost, does almost exactly what you want it to do. And so it's a lot easier to get to the point where you have something that's ready to turn into a product. On the other hand, building these ML powered products is not easy, and all kinds of things can go wrong when you do it. Let's see. I guess this video isn't working, but this video is of a child interacting with an Alexa and asking it for something innocuous, but the Alexa doesn't really understand what it's saying, and so it says something really offensive in return, right? And so it's like these kinds of issues arise when you deploy models in the real world. And another kind of like maybe less like more abstract but much larger example is an example from the Unity S1 last year, where they sort of blamed ML for $110 million of losses because of sort of bad model training. So how do we end up in the category on the left where we're building these amazing things that couldn't have existed before without finding ourselves in the category on the right, where we're building things that are offensive or lose us a lot of money? So the next thing I want to talk about is, why is this so hard? Why is it so hard to build great machine learning powered products? And I'm going to frame this by talking about what I see as sort of a few of the inconvenient truths that we may want to tell ourselves are not true, but in reality, as when you're out in the world deploying models, are unavoidable. And so the first inconvenient truth is, I'm sorry, but your users just don't care if your model is state of the art or not. So I think maybe a lot of us, if any of you have deployed machine learning models in production, maybe you've had this experience where you work for months and months to make a few percentage points improvements to your offline metric, and then you deploy the model and you run an A/B test, and it turns out that your users actually like the new version of the model less than the one that you had before, right? And so this is kind of an anecdotal experience that a lot of machine learning engineers have had, but it's also starting to be backed by research as well. So driving for like the best offline performance is not the way to build the best model. Second inconvenient truth is that if we're really being honest, most machine learning practitioners don't actually know if their model is really working in the real world, if it's actually solving the problem that it's supposed to solve. And there's a few reasons for this. I mean, the most obvious one is just, very few machine learning teams have good like monitoring and observability of the metrics for their models. But there's some more subtle reasons as well. The first is what I would call the so what problem, right? Which is that a lot of the metrics that we're taught to look at as machine learning practitioners are very, very hard to really tell whether that's actually bad enough that you should change your behavior or not. So the worst example I think of this is the things that people tell you to do for measuring distribution drift. So in the real world, data distributions change all the time. And so people will measure that they can tell whether they need to fix their model or not. But a lot of the metrics that they use to do that, like the KL divergence, are totally uninterpretable, right? Like if I told you that your data has drifted because you have a KL of 0.37 on one of your features, what does that mean, right? Does that mean that you need to fix your model? Does that mean, hey, my model is degraded, but it's not that bad? Or maybe is your model actually just robust to that small shift? It's very, very hard to tell from those metrics. So what? And then the second is the WTF problem, right? Which is that even if you know how accurate your model is, your model can make individual predictions, like telling people that global warming is a hoax, that will be really offensive to some of your users. These things will never show up in your top line metrics, but they're still really bad user experience for the people that are interacting with your model. And so it causes the users to go like, WTF, what's wrong with this model? And these are also very, very hard to detect systematically. The third inconvenient truth about building machine learning powered products is that end users are the original adversarial examples, right? Like end users are crazy. They'll find all kinds of ways to, figure out what are the weaknesses of your model and exploit it. And a couple examples I'd like to share of this is the classic, like, is it a muffin or is it a chihuahua example, right? Where, if you're a mean user, maybe you'll try to trick the model by providing examples like this. I actually think as a side note that models are probably better at people than this task at this point, but point still stands, I think. And then, another example is like my hobby in San Francisco, where there's self-driving cars driving around all over the place, is to try to test their limits, like walk in front of them, or hit the brakes if I'm driving in front of them, something like that, to just see like, hey, how well have they accounted for these edge cases? And this is like a tendency that people have when they know they're interacting with not an autonomous system, to try to find its limits. And then, lastly, and I think maybe most subtly is, and potentially the worst of all, is, let's say that you had a perfect way to detect and all these kinds of problems. Like you could tell whether your models are working or not reliably in production. You'd still be in a tough place, because unlike in traditional software, where if you detect a bug, that's really helpful because we have great tools in software like IDEs, debuggers, unit tests to fix issues that we find. In machine learning, actually fixing the issues that you discover is often really difficult. And so I think oftentimes it kind of feels like this, right? Where we're stuck running like these crazy SQL queries to pull together some data from all these different data sources to answer this like ad hoc question that we have to address this like one weird failure mode the model has. And then we have to like convince our boss that the new model we built is actually better. And so we're stuck like building random charts to try to make everyone on the team comfortable that we actually fix the issue our users are seeing. And so if you put this all together, I think oftentimes what it feels like to build a machine learning powered product is, it starts out great, right? Like you gather some data, you build a first version of the model and that data. We have good tools for this. You deploy that model into production. Often, like more and more these days, teams have good tools for that as well. And then once you get it into production, you really don't have any ongoing indication of how well it's doing. So maybe you run some spot checks. You look at a few individual predictions. You convince yourself that the model is healthy. Then as time goes by, you move on to another project. You forget about the model that you deployed until a few months later, the model has its first problem. Now, the problem is, I, as a machine learning engineer, am not really the one to discover the problem to begin with. It's like some business user or some product manager that realizes like, hey, our users are complaining about this thing, or this metric is dipping. And so then it takes them, a couple of weeks to really figure out, what's really going wrong here, what part of our system is breaking. This is already starting to cost the company money. And by the time they get back to me and they point it back to me, I've lost the context about what's going on. And so I'm stuck doing this like ad hoc analysis process to try to figure out, what is the issue with the model and how do we fix it? When I fix it and roll out the fix, hopefully we can run an A/B test or something like that to convince ourselves that we at least fix the problem in the short term. But once we do that, we're stuck back in the same position we were before, which is not really having an ongoing, continuous way to tell if our models are working and to fix them if they do break. So that's, I think, sort of how I see the problem. And the thesis that brings us to is that if you want to do this really well, like if you want to build great machine learning powered products, then do what the best teams that are doing this do, which is don't think of your job as to build a static model offline, to like do it Kaggle style, like get a data set and really spend all of your effort making the model as good as possible and then throw it over the fence to someone else to deploy it. Don't do that. Instead, what you should think of your role as a data science team is to build, ship a minimum viable model as quickly as possible. Get something that's working in production end to end. Maybe it's just rules. Maybe it's just a linear classifier. But get it out there in the world and then use the rich data that you get from end users interacting with it to make the model better. So that's kind of like the central thesis of this talk. And I think for the rest of the talk, I'll talk a little bit about sort of what I see are the pieces of that, and some of the challenges and how we at Gantry sort of aim to help with it. But I'll pause there and see if there's any questions. Cool. All right. Well, yeah, so let's talk about the components of this, right? So let's say that we want to refine models in production, the first thing that we need to do, as we were discussing before, is we need to be able to detect opportunities to make the model better. So those are, degradations in performance, cohorts where the model's not doing well, edge cases, and these like WTFs, right? The things that cause your users to like throw up their hands and be like, this prediction is so bad that I want to leave your product. But it's not enough just to be able to detect those things. We also need repeatable workflows to be able to fix issues when they do come up. Otherwise, the same issues are going to keep coming up again and again. And to prevent that, we need measurement and testing to make sure that once we fixed an issue once, ideally it never crops up again. And I think there's like a bunch of technical challenges that prevent most teams from doing this, as well as like organizational and cultural challenges. But this is sort of what I see as the main technical challenges. So even for a lot of teams, just getting all the data in one place, the predictions the model makes, the feedback that's coming in from your end users, the feedback that's coming in from your labelers, just putting it all together so you can analyze it is often a challenge. Once you have that, then, for certain organizations, like if you have, let's say sufficient scale, then just the act of like computing your metrics across all the subsets of your data often is challenging because these things can be very difficult to do once you get beyond the scale that you can compute these metrics on a single, like on your laptop, basically. Then, I think the next problem is like, let's say that you actually are not in the luxurious position of having labels all the time for all of your predictions, which in most machine learning use cases we're not. The question becomes, what proxies should we look at? How should we assess whether the model is healthy in the absence of rich, dense label data? So how do we choose metrics in the absence of feedback? I think there's a really sort of rich and theoretical problem there, as well as some practical considerations that can lead you to like an 80-20 solution. Next issue I see is root causing issues. So let's say that definitively that your metric dipped yesterday. Like my model is less accurate yesterday than it was in the 7 days prior. How do you, in order to fix that, you really, ideally, you should be able to figure out what caused that to begin with. Like, is this because my user behavior shifted in some way as a result of some external event? Is it because we acquired a new cohort of users that behaves differently than our existing users? Is it because the data pipeline is broken? Is it because, users are just like, as they use the product more, they're submitting more and more challenging inputs to our model? If we can answer that question, we're much more likely to be able to fix the issue quickly and permanently. But root causing issues in machine learning models tends to be very hard, especially if the input data to the model is very high dimensional. Then once you've root caused the issue, even if you actually know what's wrong with the model, there's kind of data collection problem that falls out of it, right? Which is, how do we gather all the data that we need to fix the model? How do we manage these sort of examples that we find as the model runs in production over time? How do we collect more examples of edge cases? And then, ultimately, like for a lot of these issues, for some issues with machine learning models, the way to fix it is, by fixing a broken pipeline or adding a rule or, limiting a particular use case, like not letting users use your model in a certain way. But oftentimes the fix comes down to just retraining your model on different data. And so deciding when to retrain your model is also a difficult technical challenge. Like, how do you know when you have enough data? How do you know when you have the right data that retraining on the model is actually going to, the benefit that you get from that will outweigh the cost? And then lastly, I guess this one's not really a technical challenge, but I thought I'd throw it in there anyway. What we found is that collaboration tends to be a really difficult challenge in this part of the process, because when you're like, as data scientists, when we're developing models, we have the luxury of not really having too many other stakeholders in the room, right? Like maybe you have to convince your manager that you're on the right track and that the model is getting better. Maybe your manager has to convince a PM that they're like, however many quarters away from being able to ship something. But as soon as the model goes into production, there's all these stakeholders that, really have, real skin in the game for how well your model is doing, right? Like if the model is performing badly for a subset of your users, then the PM who's responsible for the feature that the model drives, that's really bad for them. If the model is doing something that might cause brand risk or reputational risk, then everyone all the way up to your CEO probably really cares about that. The business stakeholders care about it. So how do you get the team on the same page about, hey, how do we define what is good enough for this model? How are we doing against that set of metrics? And how do we convince people that we're moving the model in the right direction. So these are kind of what I see as like some of the biggest challenges to doing this effectively. Happy to just dive into any of these a little bit more that folks are interested in.
Yeah, we got one. We're good.
Oh, was there a question or no?
No, there's a Zoom artifact covering some of your words on your screen, but that's about, there we go. Everybody appreciates you.
Got
Yeah,
it.
we're good.
Cool. All right. Well, I mean, I have like some material prepared on these, but I was kind of like the thinking was like, let's go deep on any of these that folks are particularly interested in. But I'm also happy to just sort of breeze through this next part and talk more about Gantry as well. But if there's any of these, I can also come back to this like after we talk about Gantry and see if there's any that are interesting for folks to learn to talk more about.
We have a question. I lied.
Mm-hmm.
Hey, this is awesome. I mean, I feel like a lot of people, it's almost like old news that people talk about models in production, but I mean, it feels original and still really insightful. Something we're wondering about is so when we have new models that we retrain and we want to deploy them, we're wondering if we should have some kind of controls process in place. So like, for example, if you're not working on a model, if you're working on like a front end application, and maybe you have a pull request that has like a button or something, like a new feature, you'll usually have like a team review that. Maybe it'll deploy it to a staging environment, and then the powers that be can approve it. But like, do you recommend a similar thing for new versions of models? I mean, I think there's use cases where I guess it doesn't matter what you recommend, like it just makes sense. But have you worked with a controls process like that before? And like, do you like any tools that do that? Because I mean, that's something that it's coming up for us and we're looking into.
Yeah, absolutely. I mean, I think this is like, I'm skeptical of trying to buy in too fully into like just applying all software engineering practices to ML, but this is one where I think absolutely people should just copy exactly what people do in software engineering, right? Like, I don't think you should ever roll out a model without, at the very least, some automated checks that convince you that the model is better than the last version of the model. But depending on your use case, and how well you feel like you understand the limits of the model's performance, that might also be a manual review. And so I think one thing we're kind of missing as a field is like, what is the equivalent of a pull request for a model? How do you as a team align on like, hey, when we're rolling out version N+1, does this pass all of our checks? And I think the components of that you need data to check the model on, and that data needs to evolve over time in a very specific way, which I'll explain in a second. You need metrics, like how are we going to evaluate the model on this data? And then you need like slicing functions to say like, looking at aggregate metrics is not enough. Your model can be more accurate, but it can be way less accurate on a particular subset of your data that you care about. Model bias, model fairness is like the most sort of visible example of this, but it's also present in like, let's say that you have a couple of customers that are more important for some reason. You probably want to make sure that your model is performing well for those customers, not just across all of your less important customers on average. So it's those three pieces. It's like, what data do we what is the evolving data set that we evaluate the model on? What metrics do we evaluate against? And then what slices of data do we break out the model along to make sure that we're not trading off slightly higher aggregate performance for much lower performance on an important subset. And to double click a little bit on the evolving data set piece, I think the mental model that I have for this is, you have a validation set, typically in machine learning. And I think like in the academic ML world, we're sort of trained to think of that as a static thing, or let's say your test set, right? Like you don't change that. Over time, your goal is just to perform better on that. In production ML, and I'm sort of borrowing this from how the autonomous vehicle companies think about it, because I think they're sort of furthest along in thinking about some of these like sort of safety and controls pieces of the process. But the way they think about this is, hey, anytime that we discover a new problem with the model, a new edge case, a new failure mode, a new like region that we're thinking about launching it in, then we should add examples of that into our validation set. And so we should almost build up this, rather than thinking about it as one validation set, we should almost build up this like corpus of validation sets over time, where the different subsets of that validation set are driven by specific like investigations into model performance that we ran. So that's how I advocate doing this. And tooling wise, like I'm very biased. I don't think there's a great tool out there for this. And we're building one, which I think is going to be very good.
No, that's awesome. I mean, we'll be shopping probably. So
Cool.
yeah, no, that's fantastic. Thanks a bunch.
Yeah. Any other questions?
Yes.
My questions may sound a little naive, but it's more of a mental confidence as you're building. So let's say you roll out a new model, you have a set of metrics you think is right, you try optimizing for those metrics, but then you start thinking, am I optimizing for the right thing? And then it starts to, as like a little like, twitch in your brain. And then pretty soon you're like, I don't know if I'm optimizing at all, because it's kind of a guess in a direction. So looking for advice, how often do you reconsider, like just pick some metrics and then let it ride? What is the interval that you go back and say, at this point, I think it's appropriate to reevaluate as to whether or not we're heading in the right direction with our metrics?
Yeah, it's a really good question. And I think, I think to avoid sort of churning back and forth, I would advocate for just being really thoughtful about what stage in the life cycle of the project you're at and focusing on that stage in the life cycle. And so to give you like the way that we teach this in the full stack deep learning class is, you just breaking it all the way down into component pieces, right? Like first thing that you do is you start with a really simple model, really simple small data set. You make sure you can overfit the model on that data set. Then you add more data. And then you get to the point where you can where you stop overfitting, right? You get rid of your overfitting because you have enough data that you're able to just have a small gap between train and validation performance. Then you look at your performance in aggregate relative to what your target is. And if you're still below your target, then you make the model bigger, you add more data, et cetera, like the whole toolkit for improving model performance. And that's the iteration loop that you're running on a single metric. I think the point where I would advocate revisiting the metric is after you've deployed the model in the real world and you see how like your end users are reacting to it, your outcomes are reacting to it. And this is, I think, exactly why shortening, tightening cycle times is so important, and why I advocate for like just putting your product hat on and just thinking about like, is there any way that we can get this out into the world, interacting with users as quickly as possible, or interacting with whatever process it's supposed to interact with as quickly as possible? Because at the end of the day, you just don't really know. You don't really know if the metric that you picked to optimize offline is going to drive the outcome that you care about until you try it. And so I think, if you're like, I think good patterns are like deploying a rule-based system before you deploy a model, deploying a linear model before you deploy a deep learning model, trying to, wrap a GPT-3 or Hugging Face model before building your own, your own, before gathering a bunch of data and training your own model. So I think I would try to use the signal that you're getting from the real world to assess whether you have the right offline metric. And the upshot of that is I would try to get your model into the real world as quickly as possible.
Cool. So move quickly. Don't let metrics, like the fear of metrics, slow you down. But then listen actively to your customers. And if you start seeing those outliers, like you mentioned, like those one things you don't detect when you're spot checking, but blow up, use that as an indication. Like maybe the model's either not ready or we do not have the visibility that we thought we did.
Yeah.
Cool. Any other questions?
Cool.
We have one more question.
It's not really a question. It's more like just adding to. If you can do A/B testing or shadow modeling before you even roll that out. Also, one thing that's actually helped me as well is like looking at Kaggle or something else to see what other metrics that some people are using in the same modeling that you're doing. So that might help as well.
Yeah, agreed. I think like, a lot of times what we see, we're working with a couple companies now that are, we started working with before they rolled out their first model to production, which is not normally what we do. Like normally we work with companies that have multiple models in production, but we thought it'd be an interesting experiment. And what we found there, which has been kind of fascinating, is that if you start by instrumenting, like you start by gathering the data you're eventually going to train the model on, you can already learn a lot about what a good model is going to look like, just by collecting that data from your users or from the real world. And then you'll be better positioned to train a model that really solves the problem. All right. I can keep going. I'm happy to come back. I mean, this is sort of like the meat of what I was hoping to chat with folks about. So I'm happy to also come back if other questions come up. But I think I'm going to skip through the next few slides because they're going into depth on a couple of the pieces that seemed like maybe less interesting for this audience. But I'm happy to, if this looks interesting, I'm happy to come back to it. But this is about some of the technical challenges for computing metrics at scale, how we think about this from an infrastructure perspective. And then I have a few slides also on root causing issues with high dimensional unstructured data, like how to think about, hey, how do we measure drift? How do we find issues with NLP data, image data? So kind of talk about our framework for that. Happy to come back and talk more about this if it's interesting. And then the sort of rest of the presentation is a little bit about our approach, like how we aim to help companies solve this problem. So I already introduced myself. My co-founder, Vicky, I know from OpenAI, she was the first engineer there, built like all of their infrastructure in the early days, went on to lead the compute team at Lyft and saw like how, both from the small company side, OpenAI at the time was a small company, and then later from the big company side, like how difficult it is to solve these ML infrastructure problems. And so we joined forces to create Gantry, and we're backed by some awesome investors. So the way to think about what we do is we start by the first value prop is just helping you get all the data in one place to solve this problem, right? So we connect to your, however you're training models, however you're serving them, and then also critically the end application that the model is a part of, because that's where you have feedback coming in from your end users. And so each of these pieces are logged into Gantry. There's different ways of doing it. The simplest way is like a, weights and biases like log line, but we can set this up in different ways. And then the things that we help with beyond that are first issue detection. So like, how do we know if this thing's healthy? Can we get an alert if something is going wrong so we don't have to babysit the model all the time? Second thing is error analysis. So if there's a problem, or if there's an opportunity to improve your model, or you suspect there might be, can we drill down and figure out what subset of my data might be causing this issue? What subset of my data is my model underperforming on? And so we have like a typical data viz dashboard that makes these type of queries really performant that you can use to inspect your data. But one of the unique things that we do is we also have like all the functionality of that dashboard replicated in an SDK, which just feels like using the pandas data frame, except for you don't have to have the data locally to use it. It's all running like on our infrastructure. So the types of slice and dice queries that you might run, like how does my accuracy differ on these different subsets of data? How is my accuracy changing over time? Those types of queries are very, very performant. And you don't need to have, like, if you have too much data to have locally, then that's fine. And then the third tool that we provide for this is called projections, which is a way of, which I'm happy to talk about if folks here are interested in unstructured data, which is sort of a way of like taking these really messy signals that you get from images or text or video or audio or whatever, and turning that in an interpretable way into some signals that you're able to monitor or use for downstream analytics. The next piece that we do is data set curation. So again, like coming back to, I think it's not really enough just to know about problems with your models. You also need to have ways to fix them. And so we are pretty tightly integrated into the labeling tools. And so we allow you to, like, if you find a subset of data that's causing you a problem, or if you have like a strategy for how you want to sample data from production to label, we can feed that into labeling tools so that you can get that data annotated. And then once you have that data annotated and you feed this back into your process, you retrain a model, redeploy it, and put it back in your application. Then, before it actually goes into your application, we help with testing and validation. So this is sort of the CI/CD piece I was mentioning before. Like, can we have a check, like a GitHub action or something like that, where we can use this as a team to decide if the new version of the model that we trained is ready to go into prod. And so just to recap, like kind of all what we talked about, Gantry is designed to help you refine machine learning powered products in production. So help you improve them over time using this, like the richest and most important data source that we have, which is outcomes, right? Like, do our users care about the predictions that we're making? Is this driving the business outcome that we really wanted to? And the way that we do that is by helping you sort of gather all the relevant data to do these analyses, detecting issues and other opportunities to make your model better, analyzing those errors to figure out, like, hey, what are the actual concrete ways to make our model better, curating data sets to fix the problem, and then finally, like, testing and validating the fix to make sure that you actually fix the thing that you think that you fixed and your whole team is on the same page about that and you don't make the same mistake twice. So that's kind of quick overview of what we're up to at Gantry. And yeah, happy to, this is sort of all I have prepared. I'm happy to take this in any direction that is interesting to folks.
Anybody else have questions? Okay, you can ask it.
I've got a tangential question, but I don't know if you wanted to wrap up anything else before, like, a broader scope of questions. It's up to you.
No, I mean, happy to, yeah, like I would love this to be interactive since it's such a small group. So just fire away.
Okay. My question is really more for you. So I think we get a lot of engineers who partner with companies or ML companies to come in and talk about a little bit about their product, but really what they've learned as they've built the product, which you've done. But what I'm kind of curious about is, you having started this company, what are some things that you are, scribbling on your book for things that you did not realize that you would learn, but have manifested themselves through your journey as CEO of an ML company?
Oh, wow. Where to begin with that question? Yeah, I mean, I think, my background, like I spent, the 3 or 4 years before doing this as a machine learning researcher, right? So I was like writing papers, writing code. It turns out that as CEO of a company, it's like you very quickly grow out of writing code. And everything that matters is like the rest of the stuff, right? Like, are we solving the right problems? Are we building the right things? Are we hiring the right people? Do we have the right processes? Do our customers like what we're building? How do we make it better? These types of questions. And so it's been a big learning journey for me, for sure. I think, some of the things that have been surprising are, like, it's, we use really good products all the time, sometimes without noticing it. We're using Zoom right now, right? I mean, I think we can quibble about how good a product Zoom is, but to some degree, like, everyone uses it, so it's at least pretty decent. I think one of the things that took me a while to realize is just how much more difficult it is to build, like a product that really works well and is delightful for users, than it is to build a really innovative research project. Like, there's just so many more details and edge cases and moving pieces to think through, and each one of those things really you have to really get right in order for the whole product experience to come together. And so I think it's it took me a while to realize, like, how much more iterative and how much longer it takes to build something really great for end users.
Cool. Thanks for the answer. Any other questions around here? No one's raising their hands. Oh, we got one. I lied. Passing the mic.
So I work with a lot of NLP type of products and some NLG where we're generating content. And I've got some where it's fairly low volume in terms of usage. And the feedback, so it's generating content, right? So the model is producing. But the feedback is very, like I've got no real test metrics. It's just, did you like it or not? Did you, because it's not a number that I can compare it against.
Yeah.
It's not accuracy, but it's usability. And it's fairly limited in terms of that, maybe it's it ramps up, but maybe in a year it's 1,000 times that it's being used. So, when do you retrain that model? And do you do it every time? Is it just any thoughts on that in terms of these are kind of in production but low volume type of products?
Yeah, you might not. You might not need to retrain those models. I think the nice thing about low volume is that you can do things that don't make sense at higher volume, right? So, if I were working on like a really low volume NLG case like that, I would probably just look at a lot of the predictions that the model is making and try to make my own assessment of, hey, when the users are not happy with the predictions the model is making, or even if they are, like how good are these predictions? Like, do we think that we can make them qualitatively better by retraining the model? So I don't have like a definitive answer for you because obviously like these low data domains are not really for deep learning are not really that well understood. But for NLG, like if you're using large language models or foundation models or whatever we want to call them, then you can also, there's all kinds of other things you can play around with, right? You can do some prompt engineering. You can change the sampling hyperparameters, right? So the nice thing that you can do is you can since you have such a limited corpus, you can play around with all those things and see how the model's predictions, like how the generations would have changed if you had made those changes on the inputs that your users provided you, and then use your sort of qualitative sense of what's good as your guide. So it doesn't feel great as engineers, but it's nice also because it's like a thing that can be very effective that you don't have the luxury of doing if you have high scale.
Yeah. All right. Well, there's no silver bullet, so I was looking for one.
Apologies. Yeah. Don't have one for you.
Any other questions? Okay, go ahead, Eric.
What do you have any recommendations for experiment tracking? That's another bunch of vendors we've been looking at. Like, what do you look for in an experiment tracker? Oh, also, sorry. And we seem to have data scientists disagreeing on what it means. Like, some data scientists will say that, no, I can't remember what I was going to say. Yeah, sorry. So what practices do you look for in experiment tracking and what's useful for you?
When I was spending a lot of time training models, I used weights and biases, earlier version of it. So, I imagine it's changed a lot, probably for the better since then. I think at the end of the day, these tools are all probably fine. MLflow is fine, Common is fine. They're all going to solve the problem for you. So I think TensorBoard is even fine, right? So to some degree, it comes down to a little bit of what's the easiest to use in your environment, like what integrates the best with the other things that you're using, and then how much do you really care about the end user experience. I think there's a differing degree of quality of end user data scientist experience for these different tools. I know that probably the ones that are built by the startups are going to have a really good end user experience, whereas something like MLflow, TensorBoard, it does the job, but it's not going to be maybe as nice of a time to use it.
Nice, that's awesome. And then also with MLflow, for example, they'll start to combine like a model registry with the experiment tracker. Like what artifacts do you think make the most sense to store? Like do you just store the model weights and you run those with ONNX, or like do you store the model weights and the inference code that does the pre-processing? Like, so I mean, we're kind of struggling because it's like, do we pickle the entire package, or like do we just have the weights? Like, do you have a thought? Like,
Yeah, it's a nuanced question. I think there's like two levels of answer to this. Like there's different goals to storing artifacts. One of the goals is reproducibility. So if you want to just be able to like make sure that you can run the same experiment a month from now that you ran today, which is harder than it sounds, then I think the things you need to save are like the data in the specific state that it was in now, the training code, and the training hyperparameters. And you you may or may not need to save the model weights. It's probably a good idea to save the model weights at the very least to just be able to like pull that artifact and run inference on it. Then there's a separate question, which is like, how do you take the output of the training job, which is like this neural network or this model of some kind, and then turn this into something that is able to, field traffic from users, or like operate as a service and make predictions in real time or in batch mode or whatever. And so the reason that's more nuanced question is because it depends a little bit on the rest of your stack, like in the rest of the product that you're building, and what the model is itself. So if you're, and what your constraints are, right? Like, so I think the easiest thing to do, and the thing that we teach in the full stack deep learning class is, just save your model weights and create like some lightweight inference code that loads the model and like calls model.predict or whatever. Wrap that in a Docker container, deploy it as an AWS Lambda, and then you're done. Now, that's not a one-size-fits-all approach, because if your model is big enough, you won't be able to put it in a Lambda. If you have really strict latency requirements, that might not work. If you're really cost sensitive, that probably won't work. So I don't think there's like one answer I can give there, but that's like, if I'm giving someone generic advice on like how to approach serving models, I think just getting in a Docker container and putting it in a Lambda is like probably the easiest way to get started.
Nice. We had like an internal a debate that kind of got heated, but basically they said the question was, should we store all the inferences or no for a model training run? Like, do you have an opinion on that?
All the predictions that the model made?
Right. Yes.
It's a good question. I don't think you need all of them for the whole training run. But I do think it's useful to store all of the inferences on the validation set, or the test set, or the training set, or all three, for at least all of the versions of the model that are like candidates for running in production. And the reason for that is that if you like, let's say that you want to roll out a new version of a model, and it's looks like the performance is about the same, and you want to figure out like, hey, how do these two models differ? Is it they're exactly the same everywhere? Is it that like one model performs a little bit better for 90% of users and much worse for 10% of users? Like, what are the different performance characteristics of these two models? Then having at least being able to recreate the inferences for those two models on a data set is really helpful, because that's like, those are the things that you're going to compare to each other.
Yeah, that's great. Like, basically store the most useful subset and not the rest. That's good. Thanks.
Yeah, and I mean, also storage is cheap, so like I would always just err on the side of storing more.
Any other questions? Cool. Well, let's go ahead and give Josh a round of applause. That was a great talk.
Thanks, everybody. And yeah, I'm happy to share my email. If folks want to chat more about any of this stuff, feel free to just reach out, or LinkedIn or Twitter or whatever. Pretty easy to get in contact with. And yeah, thanks for hanging out.
Thanks, Josh. Before you go, so MX is hosting this. Usually I say there's a few positions open. I don't think I have a position open, but we'll open soon. So you get to advertise any open positions that you have for your company. We have some students here who are wrapping up internships, and some students entering their last or second to last year of their major or their master's program, and wondering for about jobs coming up. Do you have positions that you are looking to fill?
Cool. Yeah, we do. I think the easiest way to learn about those is just to check out our website, our careers page. But we have openings, software engineering, ML engineering, as well as some, if you're more interested on like the business side of how ML gets applied, we have some openings around that as well. Yeah, if you end up applying, also just drop me a note so I know to, pay attention to the application.
Also, my team's got a position open for a senior data scientist. If anyone wants to apply, please do. Mastercard.com/careers. It's senior data scientist. Brett Ragazine's the manager.
And I may have missed it, Josh. Do you have a careers page on your website? Where can they go?
Yep. Gantry.io, and then there should be a careers link there.
Thanks everybody for coming, and thank you again, Josh. We'll see everybody hopefully next month. So feel free to hang out, chat, and get some more food. And thank you again, Josh, for speaking with us.
Thanks, everybody.